There's a form of ice that we think forms deep in the atmosphere of Uranus, the planet, because it sounds like anus. It's an electrically conductive form of ice.
What if Antarctica's icy silence is hiding something unimaginable?
One of the things I find most striking is the presence of Antarctica on ancient maps, because we didn't discover it until 1820.
Scientists have uncovered a massive, unexplained heat signature beneath the ice, so vast it's puzzling researchers. It isn't science fiction, it's real data that's raising serious questions. Even physicist Brian Cox has taken notice, hinting at possibilities far beyond conventional thinking. Could this anomaly be evidence of something ancient, hidden, and forgotten? Whatever it is, it might change everything we thought we knew about Earth's deep past. A cold mystery in the deep south. At the very bottom of our world lies a continent most of us rarely think about, Antarctica. It's a place of silence, locked beneath ice sheets so thick they could bury Mount Everest. But lately, scientists are listening a little more closely, and what they're hearing, or rather seeing, might just shake the foundations of everything we believe about our planet's history. In a remote region called Wilks Land, satellites have picked up something strange, a massive heat signature, not a little bump, not a glitch, but a 300-mile-wide geothermal anomaly deep under the ice. First detected by NASA's GRACE satellites, this anomaly behaves like a buried mass. It's dense, it's warm, and it shouldn't be there, at least not according to standard geology. Enter Brian Cox, the renowned physicist and science communicator, known for making the cosmos feel poetic. During a speculative discussion, he posed a chilling statement. Humanity may not have come first if the image is real. Now, Brian Cox isn't claiming aliens built a city under the ice. He's not putting on a tinfoil hat. What he's doing is what science does best, asking the hard, strange, often uncomfortable questions. What if what we're seeing isn't just a weird rock formation or an old volcano? What if it's something more? Something lost? Something not human? What we know so far. Beneath the thick, frozen surface of East Antarctica lies a puzzle that continues to baffle scientists. A massive gravity anomaly centered in a region known as Wilks Land. This is no minor irregularity. Stretching approximately 300 miles in diameter and estimated to be more than 500 trillion tons heavier than the surrounding crust, this subsurface feature has prompted questions that reach far beyond traditional geology. It wasn't spotted through photographs or ground exploration, but rather through subtle shifts in gravity detected from space. The anomaly first came to light thanks to NASA's GRACE mission, short for Gravity Recovery and Climate Experiment. Launched in 2002, GRACE consisted of twin satellites that orbited Earth in tandem, measuring minute variations in gravitational pull. As the satellites passed over regions of differing mass, one would speed up or slow down slightly in response to the gravitational tug below. These movements were recorded with astonishing precision, allowing scientists to build detailed gravity maps of Earth's surface and, more importantly, what lies beneath it. Over Wilks Land, GRACE detected a peculiar mass concentration, commonly referred to as a mascon. It was dense, immobile, and buried deep under several kilometers of ice. While gravitational anomalies are not unusual across Earth's complex crust, this one stood out for both its size and shape. It defied easy classification, leading researchers to begin asking deeper questions about what could possibly cause such a signature in a region previously considered geologically stable. But gravity wasn't the only strange signal coming from the area. Subsequent studies revealed an unusual amount of geothermal heat rising from beneath the ice sheet. In Antarctica, where vast subglacial lakes and volcanoes are known to exist, some geothermal activity is expected. Yet this particular region showed heat levels that were both unexpected and difficult to trace to a known volcanic system. The heat flux pattern didn't match any recognized tectonic or mantle-based explanation. Ice-penetrating radar and seismic surveys added to the mystery, revealing odd sub-ice formations that didn't quite resemble standard geological structures, nor could they be definitively explained away. Scientists naturally turned to the most plausible explanations. One prevailing theory suggests that the mascon could be the scar of a massive asteroid impact dating back 250 million years, an event that may have contributed to the Permian-Triassic extinction, the most severe mass extinction in Earth's history. If this were true, the object that struck Earth could have created a deep, long-buried impact crater, with the mascon representing the dense remains of the impact site. Another possibility involves mantle plumes, columns of hot rock that rise from deep within the Earth, sometimes creating volcanic hotspots like those beneath Hawaii. While mantle plumes could theoretically explain some of the heat, they don't account well for the gravity data recorded in Wilks Land. Researchers from respected institutions such as NASA's Jet Propulsion Laboratory and Cambridge University have approached the anomaly with both interest and caution. As some have pointed out, Earth is not a perfectly symmetrical sphere. It's full of natural inconsistencies and irregular mass distributions. Still, even conservative voices in the scientific community admit that the anomaly beneath Wilks Land is unusual and merits further investigation. It's a strange puzzle piece that doesn't quite fit the rest of the geological map, and it leaves the door open for possibilities we may not yet fully understand. While some theories fit comfortably within established science, others push the boundaries of what we currently understand. So, what are the main ideas, and what wild possibilities might still be lurking beneath the ice? Mainstream versus speculative. When scientists encounter anomalies like the one beneath Wilks Land, their first instinct is to search for natural, well-supported explanations. This is the bedrock of the scientific method, testing what's likely before entertaining what's extraordinary. And in the case of this Antarctic anomaly, there are a handful of mainstream theories that attempt to explain the gravity and heat signatures through familiar geological processes. The most widely discussed theory is that the anomaly is the remnant of a massive asteroid impact, possibly one of the most catastrophic in Earth's history. Some geologists believe this could be the scar of a cosmic event dating back around 250 million years, coinciding with the Permian-Triassic extinction, when nearly 90% of marine species and 70% of land animals vanished. The idea is that an enormous asteroid struck the Earth, and over time, ice and sediment buried the impact site. What remains could be a deep mascon, a leftover gravitational fingerprint from the intense compression and structural changes caused by the impact. It's not unlike the mascons found on the Moon beneath its large craters, which still affect lunar gravity today. Another strong candidate is the presence of a mantle plume, essentially a deep-seated thermal upwelling from Earth's mantle that heats the crust above. These plumes can give rise to volcanic islands or rift zones, and while they don't usually create gravity anomalies of this magnitude, a particularly active or ancient plume might explain both the geothermal heat and the subsurface density detected in Wilks Land. Still, critics of this theory point out that no surface volcanic activity or clear rift structures have been associated with the region, which weakens the case. Despite these natural theories, the data doesn't offer a perfect fit. That's where the door, ever so slightly, cracks open to more speculative possibilities. One of the most provocative ideas suggests that the anomaly might be artificial in nature, the remnant of a long-lost civilization, buried and preserved beneath the Antarctic ice. This doesn't mean alien spacecraft or science fiction tropes. Rather, some researchers and writers, particularly in the alternative history space, propose that humanity, or some other intelligent species, may have developed advanced technology long before our currently accepted historical timeline. Proponents of this idea often point to ancient maps like the Piri Reis map, which some believe show Antarctica without its ice, implying ancient knowledge of the continent's true shape. Others suggest that if an advanced civilization had once existed before the last ice age, perhaps tens of thousands of years ago, it's not unreasonable to think that its remains could have been buried by shifting ice sheets and forgotten by time. If so, a large, dense, and oddly warm object beneath Antarctica might not be a natural feature at all, but the final trace of a lost world. While mainstream science hasn't found concrete evidence to support such claims, the idea is compelling. It plays into a deep-rooted human curiosity, the possibility that we are not the pinnacle of Earth's history, but one chapter in a much older and more mysterious book. Whether it's pure fantasy or a question worth asking, depends on where you choose to draw the line between skepticism and imagination. The Brian Cox effect. When someone like Brian Cox speaks, people tend to listen, not just because he's a scientist, but because he knows how to make science feel like a story worth hearing. With a background in particle physics and a calm, wonder-infused delivery style, Cox has become one of the most recognizable voices in science communication. His statement, "If this image is real, then humanity may not have come first," isn't a declaration of belief. It's an invitation, a spark meant to ignite the imagination while keeping one foot planted in science. Cox is no stranger to strange ideas. As a professor and television presenter, he spent years explaining black holes, quantum mechanics, the origins of life, and the nature of time. What sets him apart is his ability to hold space for awe without abandoning rationality. So when he references an image, a satellite scan or heat map, and wonders aloud if it might suggest the presence of something pre-human beneath Antarctica, it's not clickbait. It's curiosity. It's a question designed to challenge the assumptions we carry about our place in Earth's long, complex history. The key phrase in his quote is, "If this image is real." It's a conditional statement, grounded in skepticism. That kind of language is crucial in scientific discourse. It doesn't assert, it probes. It says, let's look more closely. Let's not dismiss the unusual just because it makes us uncomfortable. This is where the value of people like Brian Cox becomes evident. They act as bridges between rigorous academic research and the broader public consciousness, encouraging us to ask, what if, without falling into the trap of conspiracy thinking. What's fascinating is how such a simple question can ripple out into much larger themes. What does it mean if we're not the first? What kind of civilizations could have existed before us, and how would they differ from ours? Would we even recognize their remnants if we found them? Cox's musings tap into those deeply human questions about legacy, time, and the unknown. They blur the line between science and philosophy, between data and dreams. There's also a practical side to this kind of imaginative speculation. Throughout history, some of the biggest scientific breakthroughs began as questions that seemed outrageous at the time. Plate tectonics, black holes, quantum entanglement, all of these were once fringe ideas. It took scientists who were willing to entertain the improbable to push at the edges of accepted knowledge before those theories found solid ground. In this way, imagination isn't the enemy of science. It's one of its greatest tools. Cox's quote may be just one sentence, but it captures a powerful mindset, a willingness to question everything, even the idea that we're the first intelligent beings to walk this planet. That doesn't mean we leap to conclusions, but it does mean we stay open to possibilities. Because if there's one thing science has shown us time and time again, it's that the universe is always more mysterious than we expect. So why Antarctica? What makes this frozen continent such a unique and mysterious place for discoveries like this? A continent of secrets. Antarctica is one of the last truly mysterious places on Earth. At nearly 14 million square kilometers, it's larger than Europe, and yet over 98% of it is buried under a frozen shell that, in some places, is more than 2 miles thick. Unlike other continents, Antarctica doesn't have bustling cities, highways, or ancient ruins exposed to the elements. Instead, its secrets are locked in ice, hidden from view, and incredibly difficult to access. This makes it the perfect place for both scientific discovery and wild speculation. Despite its remoteness, Antarctica has long fascinated explorers and scientists alike. What lies beneath all that ice? Could entire mountain ranges, cave systems, or ancient lakes be hidden under the surface? In fact, they already are. Using radar and seismic mapping, scientists have discovered vast subglacial features, such as the Gamburtsev mountain range, which rivals the Alps in height, and massive liquid lakes like Lake Vostok, sealed off from the surface for millions of years. In 2013, researchers even found microbial life in subglacial lake water, suggesting that life can survive in environments once thought impossible. But discoveries like these only deepen the mystery. If mountains, lakes, and life can exist beneath Antarctica, what else might be down there, still untouched? still waiting. The region's inaccessibility makes it a blank canvas for both scientific hypotheses and more fringe ideas. Everything from lost civilizations to secret military bases has been suggested over the years, often without evidence, but not always without intrigue. Throughout the 20th century, Antarctica became the subject of strange claims and conspiracy theories. Stories about Nazi bases under the ice, UFO sightings, and hollow Earth entrances have floated through popular culture, sometimes fueled by real military expeditions and classified documents. While these tales rarely hold up under scrutiny, they reflect something deeper, a sense that Antarctica is simply too vast and too unknown for us to rule anything out with absolute certainty. Even without the speculative layer, the continent still holds enough genuine scientific puzzles to keep researchers busy for decades. Its thick ice sheets preserve Earth's climate history like pages in a frozen book. By drilling ice cores, scientists have traced atmospheric conditions back hundreds of thousands of years. These records help us understand how the planet has changed and how it might change again. At the same time, satellite data is showing strange surface movements, shifts in gravity, and unexplained heat sources, like the one found in Wilks Land. The very nature of Antarctica, the way it resists exploration, shields its past, and withholds answers, makes it the perfect stage for questions like Brian Cox's. If something were to be hidden from history, intentionally or naturally, there are few better places than here. The continent's extreme conditions, isolation, and vast unexplored regions make it both a scientific frontier and a mythic landscape. And whether it holds volcanic hotspots or something truly unexpected, Antarctica isn't done surprising us yet. Scientific method and the value of anomalies. Science is often misunderstood as a collection of facts or rigid rules, but at its core, it's a process, a way of asking questions, testing ideas, and challenging assumptions. When something like the Wilks Land anomaly appears on a satellite image, scientists don't immediately leap to wild conclusions. Instead, they treat it as an anomaly, a curious data point that doesn't fit expectations. And in science, anomalies are often where the most exciting discoveries begin. Anomalies force us to pause and reconsider. They ask us to look deeper, to collect more data, and to revise our models of how the world works. Historically, many breakthroughs have come from anomalies that puzzled researchers at first. Take the famous example of the orbit of Mercury, which didn't quite match predictions from Newtonian physics. This discrepancy eventually led to Einstein's theory of general relativity, a radical shift in our understanding of gravity. With the Antarctic anomaly, scientists apply the same careful approach. First, they verify the data. Is the gravity signal real? Or could it be a measurement error? Then they explore all possible natural explanations, from ice sheet dynamics to volcanic activity. If no existing theory fits, new hypotheses emerge, and experiments or observations are designed to test them. This iterative process guards against jumping to conclusions while remaining open to revolutionary ideas. The scientific method also values skepticism and peer review. Every new claim is rigorously scrutinized by experts who attempt to replicate findings or find alternative explanations. This helps weed out errors, biases, and unfounded speculation. It's why, even with tantalizing anomalies, mainstream science remains cautious about embracing claims that suggest lost civilizations or alien artifacts beneath Antarctica. Yet, the very caution of science doesn't mean it rejects the possibility of extraordinary discoveries. On the contrary, it's precisely this rigorous methodology that enables us to separate fact from fiction over time. By framing the Wilks Land anomaly as a mystery to explore rather than a solved puzzle, scientists maintain the balance between wonder and evidence. They invite curiosity without compromising on critical thinking. This approach is vital because it protects science from two extremes: dogmatic dismissal of new ideas and reckless acceptance of unsupported theories. When Brian Cox or other scientists express cautious wonder, they embody this balance. They encourage us to embrace uncertainty as a natural and productive part of discovery, because sometimes the weirdest, most unexplained data points are the keys to understanding something entirely new about our world, and maybe even ourselves. In this sense, anomalies like the one beneath Antarctica are not threats to knowledge. but opportunities. They remind us that Earth's history may hold secrets still waiting to be uncovered, that our scientific journey is ongoing, and that the universe's complexity is far richer than we often imagine. What if this image is real? The anomaly beneath Antarctica's ice remains unexplained, a gravity and heat signature that resists easy answers. Scientists lean toward natural causes like ancient impacts or geothermal activity, but the mystery endures. Brian Cox's question invites us to think bigger. What if we've overlooked something buried deep in time? The beauty of science lies in curiosity, not certainty. Whether it's geology, lost history, or something we've never imagined, the answers may still be frozen beneath the ice, waiting for the tools, the courage, and the questions bold enough to uncover them. Write your theory below and let us know your thoughts. Support the channel by clicking on the subscribe button. Thanks for watching.